Here we go. Are you ready for lesson 553 using product to sum identities? We're going to be looking in the book of pages 350, 351, examples 7 to 9. I bet you are just looking forward to lesson 5 going away and dying in a hole. And same thing with chapter 5. But I told you this is hardest one, I think. Hardest chapter. When we're done with this, you can celebrate, you can do a dance, just go down to the beach, whatever you need to do. And I am sick and tired of typing these things out. These things take forever to type out all these steps. So I'll be pretty happy about it too. I'm looking forward to doing matrices in the next chapter. Now, you obviously you're going to need to take notes. And you got to have your book. And you're going to want to make sure that you have all your identities down and handy. I've got our handy dandy sheet here with even odds and double angles and half angles. And today we're going to be looking at product to sum and sum to products. Look at those things. Aren't they ugly? But as long as we can identify two different angles, then we just plug them into this little formula and do a little bit of subtraction and addition. And we'll get to answers pretty quickly. These are not seriously complicated. You just have to do it one step at a time. And hopefully I'll show you that. This should be a short video. Should be. Okay, I'm going to show you guided practice 7A, 8B, and 9A. So I'm going to give you one more example than what you got in the book, and I'll lay it out and I'll talk you through it, and then there's your homework assignment. It's not a lot of stuff, but it'll get you into these, using these equations in a practical way, coming up with some answers. Let's get right to it. Okay, so here's guided practice 7A. Maybe you've already looked at example 7, where they use an identity to write a product as a sum or a difference. And the one in the book was cosine of 5x and the sine of 3x. Mine is sine and cosine. Sine and cosine. So what do? We go to our formulas and we find the one that's sine, cosine. Nope, that's sine, sine. That one's cosine, cosine. There it is. Sine, cosine. This is the formula that we use then. And we identify what's the alpha angle and what's the beta angle. And then we'll plug it into this formula right here. All right, so alpha is 4 theta and beta is plain old 1 theta. And all right, there's alpha, there's beta. We plug it into the formula. 1/2 of sine, and it's alpha plus beta, plus the sine of alpha minus beta. And 4 of something plus 1 of something is 5 of something. And 4 minus 1 is 3. So that's what this one boils down to very quickly. And since they're both sines, well, this doesn't get too seriously complicated here, right? We'll do the FOIL method, and we go 1/2 times this and 1/2 times that, and we get 1/2 sine of 5 theta plus 1/2 sine 3 theta. That's all you do, because example 7 just says write as a product as a sum or a difference. And we just turned this product that was up here, a product, something times something, we turned it into something plus something. And that simplifies things a bit. If we knew what the angle was, we just plug it in, multiply it by 5, multiply it by 3, do the math, and you get an answer. But that one, you don't have to do all that. They just ask for you to write it as a sum instead of as a product. Here's the next one, example 8. Use a product to sum or sum to product identity. And 8b has these two angles. And I decided I would pick B because I know that Barrett loves radians. Okay, and so you have to think in terms of fractions when you're doing it in radians. Not terribly complicated, because this one is a cosine minus a cosine. And so we go to our laws and we say, oh, okay, there it is. Cosine alpha minus cosine beta. This is a sum to product. It's got two things added or subtracted. So over here, this is the formula that we use. As long as we identify what alpha and beta are, we just plug them in and we see where that goes. So there you go. There's our formula that we use. -2 sine alpha plus beta over 2 times the sine of alpha minus beta over 2. And now we think in fractions. 7/12 plus 1/12 is 8/12. And 8/12 is 2/3. 7/12 minus 1/12 is 6/12, or 1/2. So that's where the 2 pi over 3 comes from, and the pi over 2. And the next step would be that those have to be divided by 2, or dividing by 2 is the same thing as multiplying by 1/2. 2/3 times 1/2 is pi over 3. 1/2 times 1/2 is 1/4, pi over 4. And we can go and look on our unit circle, and we can find a value for the sine at pi over 3. We can find another one for the sine at pi over 4, and we plug them in. Sine at pi over 3 is square root of 3 over 2. Sine at pi over 4 is square root of 2 over 2. And this right here is math. I think you've seen this before. Math. It's math, right. Square root of 3 times square root of 2 is square root of 6. That negative 2 gets multiplied in there as well. And 2 times 2 is 4. The negative 2 and the 4 can simplify, can be brought down to negative square root of 6 over 2, and you're done. You've reduced it to the lowest terms. You're not going to do any calculating with square root of 6. Shame on you if you were thinking about that. That is the correct answer. And we can say QED. Look, we demonstrated that what it's equal to. One more example, example 9. Solving an equation using a sum to a product identity. Look, it's a sum. Something plus something else. So we go to our chart and we say sine plus sine. Sine plus, that's this one here at the top. Sine alpha plus sine beta equals 2 sine alpha plus beta over 2 times cosine alpha minus beta over 2. And we say, okay, no problem. I can do that. Let's just identify what alpha and beta is. There's alpha, it's x, and beta is 5x. So we plug those in where alpha and beta go, and alpha and beta go into the equation. Okay, so we get that 1x plus 5x is 6x. 6x over 2 becomes 3x. And here we have 1 minus 5. That makes a negative 4. Negative 4 divided by 2, it gives us a negative 2x. Over here, we have to be careful because the cosine of a negative something something is just cosine. It doesn't matter if we go up or if we go down on the unit circle, the cosine values stay the same. So this is cool. It takes that negative out of the equation altogether, the even, odd identities. They're on my little chart here. See this? Cosine of negative angle equals cosine of the angle, just to prove to you that it's true. So that means our equation boils down to 2 times the sine of 3x times cosine of 2x equals 0. And then we just split that up. The zero product rule tells us that this first half equals 0 and the second half equals 0. And if we take this and divide everything by 2, we'll get the sine of 3x equals 0. That boils down to the fact that 3x must equal, we say, where on the unit circle the sine of an angle equals 0, it happens at 0 and at pi. And then if we just divide both of those by 3, well, 0 divided by 3 is 0, and pi divided by 3 is pi over 3. And there you got an answer. You got an angle that you could plug in at the beginning and make this thing true. For, for the other part of it, we've got the cosine of 2x equals 0. We look on the unit circle and we say, where is the cosine of an angle equal to 0? It's equal to 0 at pi over 2 and at 3 pi over 2, at the top and the bottom of the unit circle. Okay, but that's 2 times an angle. We want the angle itself, and so we divide both of these by 2. Pi over 2 divided by 2 is pi over 4. 3 pi over 2 divided by 2 is 3 pi over 4. And there you have your answers. This one has 4 solutions. You probably should go back and check to make sure that that works with the original sum. The sine of an angle plus the sine of 5 times an angle equals 0. You can verify that those things are true. But there you go. You get some answers there, and that's it. So there's examples 7, 8, and 9. Check the first page or in your handouts to find out what it was that I was asking you to do for homework. Oh, there it is. 37 to 43 and 48 to 52. And if you need to, you can go back to this and pause it at any place and figure out how I went from step A to step B to step C, or where my answers came from. I'd suggest you do that. Use the pause button. The pause button's your friend. Definitely pause it and take notes. Do whatever you got to do to get this stuff down.